So, yes, I will talk about Yocto and about how to utilize Yocto to create a research target for intrusion detection. So, first about me, I just finished university last year and I'm working for the last 4 months now for Volkswagen Infotainment. And yeah, part of this talk is based on my master thesis. So there's where the problem comes from. So I will first give a short motivation and explain you how Yocto works, so the basics, and how to build your own embedded Linux with Yocto. And yeah, the second part is about sensor fusion. So we want to utilize Yocto, and yeah, we need a target to build, and it's a target for researching sensor fusion in the intrusion detection area. And therefore we need sensors and vulnerabilities. And then I show you in the end how to use it all together. And first of all, what is intrusion detection? So if we look at embedded systems in the area of IoT, or because it's Volkswagen Infotainment, we look at cars, and they are all connected to the internet right now. So you get remote updates, you want to collect data, you send it to a backend. And of course, criminals also like that. You have an internet connection, you can be anywhere in the world and start probing IoT devices. And yeah, for cars, it is car theft, or the other way around. If you own a car and you did not buy every function it offers, and it might have some extra function behind a software protection, you might try to unlock this. And yeah, if you can do it with your own embedded device, you can do it with all the same embedded devices. So you have a good scalability factor, and you can start selling it and yeah, make some money out of it. And this is where intrusion detection comes in. So we want not only have the normal process matters of adding some kind of encryption to it and to isolate your processes, but then if you have a developed running system, you will have this live system where you still collect data about the current system state, and you want to use that data to decide if something is suspicious, if we're currently getting hacked. So because of course nothing is perfect, your software, even if you checked it before delivery, it might still have some bugs and some exploits in it. And why do we need a research target for intrusion detection? So I studied here at Ruhr-Universität, and there's a lot of web security going on, and there you have like a big ecosystem, mostly driven by OWASP and some others. They provide like the security shepherd, which is a virtual machine you can download. You run it in a local virtual machine. You should not put it on the internet. And you get a big collection of vulnerabilities. And you just start exploiting, learning, and improve your own security mindset. And in embedded, so it was mostly driven by me looking for something for my master thesis. And I could not find a good project where it would be as simple as just downloading and starting. So I made myself on the way to build it with Yocto. And we're talking about automotive systems. We are not caring about cycle times. We have a lot of RAM, we have 4 cores, and just larger systems than in the most of the previous talks. And now we come to the Yocto part. So first of all, who of you heard of Yocto before? Yeah, quite a few people. This is good. And it's a tool to build your own embedded Linux distribution. It comes with BitBake, so from the Open Embedded project, and it provides you already a reference distribution, which is quite nice if you never did it before. And it's also hardware independent. And yeah, I would explain the main functionalities in recipes and layers. So Yocto layers, they are quite nice from an organizational point of view, because if you check out the Poke GitHub project, you get like this big folder, and then you have in here, this is one Git repo. You see all the blue sub-repos in here. Those are, each of them is a layer. So what does a layer do? It bundles related sets of information, so configuration files, recipe files, metadata, and yeah, for example, the SE-Linux meta SE-Linux Yocto layer gives you all the tools you need if you want to use SE-Linux on your system. There is one special kind of layers, so-called board support packages. As I said, it's hardware independent. So most of the silicon vendors ship some kind of board support layer, which contains all the files you need to develop against one specific hardware. You can always also choose the QEMU target, and then you have a completely virtual target. And yeah, then these layers can be dependent on each other, and you can stack them over each other. So you have down here the board support layer, then some extra software, and I took as example, there's the meta virtualization layer, represented with Docker here, where you have all functionalities on top of the normal software just to run Docker. And yeah, inside of these layers, you have recipes. And this is basically describing how you build a component for your operating systems. And yeah, they are then consumed by bit, bake, and build. They start with a bit of metadata. So you have summary, description, also a license file, which is quite nice if you use it in a corporate context, because you can be license compliant. And you have dependencies, so also recipes if you build software which is on a higher level and you need something below it, for example, a database server. In this case, it's MariaDB and a web server Apache. Then you can specify it, and BitBake handles building all the dependencies you need. And after the metadata, you have the build instructions. So for example, here you have the Git repository, the revision number, and some extra files you want to include. And building is, if you have a simple project with only a CMake file, BitBake takes most of the work. If you need more, you can specify it in here. And you also have installation instructions. This is just an example. You can do far more with it. You can package it into packages for installation and additional things, which I won't explain because you could talk an hour alone just about Yocto and BitBake. As I explained, you have layers, and sometimes you have some software in a different layer, which you just want to change for your purposes. And therefore, you can also append two existing recipes. And you don't need to copy, you don't need to rewrite. You just, for this example, I used the installation instructions. So MariaDB has a step called skip networking, which you can just remove with a set befehl. And then you have your own configuration. You don't need to touch it after deploying or after building. You have it all ready to be packaged. And the packaging is done with images, which are, again, recipes. And they are a bit different from the content. So you have these image install blocks where you can list all the components that you want to have in your operating system. So here, for example, init. And there are also groups of packages together. If you think of Aptitude or any other package manager, they are provide you kind of the same features. You either install each software on their own, or you just say, give me the whole package and everything in it. And yeah, this is also given by Yocto. Then you can also build on top of existing images. I used here as a Linux image and the extra users image, which provides you additional users. And then you can set further parameters, in this case, passwords for the users which are then on your system. So this is directly the first vulnerability, because if you look into OWASP top 10 for IoT, they say hard-coded passwords. So you have them in one distro, you ship it to all targets, and all have the same password. Yeah, and as an output, you get either a flashable image if you use the board support layer, or you get a simple QEMU image, which can run without any hardware dependencies. So how can we do it now more special for intrusion detection? So we need some sensors to see what's happening on top of our target. So I chose 3 sensors. The first one is ATOP. Second one is a system call traces obtained by eBPF. And the third one is the audit log from SLinux. So ATOP is quite similar to the Windows Process Manager, which you might all know. So it gives you here CPU load, memory load, and some network load. And every time your system is a bit strange, you might open it, find the one acting strange, and just kill it. So ATOP is quite similar for Linux, and it also brings you logging capabilities, which look like that. I hope for the last lines you might see it. It might be a bit small. So you have a general part with information like how many threads does your process already have spawned, and a CPU part, memory part, disk part, and network part, which are identified here in the front. Then you get some general information like timestamp and process ID. So all the lines here are generated for one timestamp. So for each process you get 5 lines. So one each in every category. And for all processes currently running, you get this 5 lines, which is quite a lot of information directly. And next to the process ID, you have this domain-specific info, like I just showed, percent of memory use, CPU use, and network use. So this is what ATOP then produces as a sensor. And the second sensor is eBPF. So eBPF is a framework. I wrote just a simple application which uses eBPF. So how it works is you have a kernel runtime with a just-in-time compiler and a verifier, where you can write your own script, which is quite similar to a C program, just in a safe and secure way, and it definitely terminates. And you get also provided by eBPF some hooks. So what I did, I simply hooked to the system call API of Linux. So every time one process issued a system call, I could then jump in there and log the system call and the calling process, which then was forwarded all the way up with a ring buffer and stored also in a log file. So I just used it offline. Everything I got, I put in log files and later used it. It's nothing like feeding it into a live engine and working directly with it. So I pressed the wrong button, sorry. The last one is SLinux. So it's not really, SLinux itself is not really a sensor. It's a mandatory access control tool provided by, so it was first developed by the NSA and is now part of the Linux kernel. It's open sourced and maintained by a special group. And it works with SE/Linux identities and roles. So all files in your system need some additional information. So you might just know how it works in a classic Linux system. You have an owner, a group, an owner and a group. And then you get this additional fields from SE/Linux with the SE/Linux user and SE/Linux role. We won't look into type and level. They are for specific policies and quite complicated. And so your file has the user system U, for example, and your standard user has the user U and the role user R. And you have here the role of the file. And if this user would try to access a file with that configuration, you would get a violation. So access is denied, and you get an additional audit log. So I grabbed for all the existing audit logs for SE/Linux. In a perfect system, you wouldn't have any logs because everything would work fine. But as it is also quite hard to configure, you often have some false positives and some accesses which are just there. If you don't have a good maintainer who clears it all up, it will happen sporadically. And this is the part for the sensors. Next is the vulnerabilities. And before coming to the vulnerabilities, I would give you a short explanation on how an example exploit chain would work. So what would an attacker do if you get a chip in your hands and know you have some interface to talk with the chip? The first step an attacker does is it tries to find any kind of breach. So I did not mention any reconnaissance steps of finding first out what's running on the target and so on. So for example, this chip has a web server running and you get some remote code execution because it's not secure. You would have established foothold. From there, you would try to escalate your privileges. You want to become the root user. And if you have the more rights you get, the more you can find out about your target. And you can find out which software is running, which users are connected. Do we have any stable connections to the internet? Do we have some hard-coded passwords for online databases, which you might want to exploit? And if you know enough, you can move to the next target. So if you think of the car domain again, you have one processor in your car and you got access, and you got a network with a lot of other ECUs in it. You want to try to hack the next. Or if you are on a really small embedded device, which you have at home, so like a smart thermometer or so on, you might want to get to the cloud or to the next target in your home network. This is called lateral movement. And then you want also to maintain persistence. This can also happen earlier. As soon as you do, the next time the target starts up, you don't want to start from the beginning. So you want to come back with a rootkit or something just the moment the target starts again. And whatever is your mission, you can then conclude it. And for me, because I had a limited time developing this whole thing, I could only do the first step, establishing foothold. So I used 3 different methods. The first one is SQL injection, password brute forcing, as I showed, the standard passwords in the beginning. They are not very secure as well. And some kind of cross-site scripting. And I want to add further stages in the future if I have time, but for now, this is all what's available. And the vulnerability to access all this is the damn vulnerable web application. It's an open source project, and it's quite established in the web security area. It's, of course, not an embedded project. You wouldn't find a web server on a really small device, but there was no better project to put on the target. So that's all I have for now. And yeah, it works on top of a web server stack. So I also thought about different possibilities, but they are not yet there. And yeah, so the last thing is how to use it all together. And so back to the motivation. This is then, so I did all the steps up to here, just to then write a thesis on top of that. And the aim of doing this is that it can be easily deployed to the next person so that he doesn't have to do all this again. And yeah, so we used it to generate a data set. We have a cloud server, which is a Ubuntu VM, and the embedded device is, in this case, the Raspberry Pi running the Yocto image. And we have a Kali Linux VM, which attacks this device. And yeah, for the logs, to get them all out, we have UART, which then just grabs the logs at the end. And yeah, generating a data set is mostly doing the same stuff over and over again. So I started the supervised part with a normal run, and then we rebooted. So in the normal case, we have the Ubuntu VM just requesting specific pages from the web server, having some kind of normal load. Then under the run under attack, we have additionally to the normal load some Kali Linux script, some Metasploit scripts, which were abusing this web server and getting access, getting remote code execution. And then we switch back to a normal run. So always reset to a common level. And the results are grouped by the trace groups. And this can then be used to do some machine learning. So I used ensemble models for that, where so here the classification algorithm is a machine learning algorithm. So you think of a neural net or a decision tree, and you just take all the traces. It's not so I would like to show you like this is normal behavior and this is attack behavior, but because we have so many parameters, it's not distinguishable by the plain eye. That's why we used some machine learning and data-driven techniques, which then give you a likeliness score and say, yeah, this is most probably an attack, or this is most probably normal. And then we do this for each trace group, combine it, and have a final decision. So that's for the using part of the Yocto target. To conclude, the good things about Yocto is you can easily reproduce it. So you did it once, and if you can make it available to the next person, they don't have to understand Yocto. It's quite a hard learning curve in the beginning. Some of you might know. It's a lot of things you have to know just right at the start and get it right. And you can, if you've done it once, you give out a flashable or a QEMU image, and the next person doesn't want to know Yocto. You can also extend it by simply adding more scripts, more recipes to the target, recompile it, rebuild it, and it stays basically the same with some additional features. And so further plans are to extend this project with new vulnerabilities and new sensors, and also new connections. So if you have some cables out, or we have the QEMU target, we can also use CAN or LIN or other connection techniques. I hope I can publish it soon. I'm currently collecting all the OKs. And I hope I can continue this in the future. So, do you have any questions?
All right, who's got the first question? Paul is raising his hand. Okay.
So you are rebuilding the entire Yocto image for each change in your vulnerabilities set, or are you using package management, and in what way?
I just built it like once and then had one working solution, which was then, so because it has this collection of all vulnerabilities, I could then work on the higher level without changing the Yocto.
I would suggest that you take a look at adding package management, because that way you could add more vulnerabilities without having to do the whole system. Also, package managers are great for vulnerabilities.
Yeah, that's a good point. Maybe.
I noted that in the end, for the intrusion detection, you only used your ATOP and something strange there. So you didn't actually look, for example, at the SE Linux logs, which are probably perfect for intrusion detection.
Yeah, this comes for the point that I only do the initial access. So by then I could not trigger any specific, so without going further and then running some real code, some payload on the target, it did not change anything in the SE Linux. So, but with more attacks, you can then use it.
Next question? No more questions? Okay, so if questions arise later on, I guess Felix is going to be there tonight anyways, because we're grateful to be invited at his company. As you may have noticed on the right-hand corner, it says VW Infotainment. And with that, let's connect. I heard that some people that are here that actually were searching for a new job. And I guess that if you tonight are still interested in a job at VW Infotainment, then you could just probably approach Felix, or he will forward you to the correct person. So thank you very much, Felix, and thanks to Volkswagen once more.